Hello students, this video will be on recrystallization. I hope you enjoy.
The science of how recrystallization can purify an impure compound. An impure compound, benzoic acid, is mixed with a hot solvent, water, which forms a saturated solution, allowing for crystallization to occur. Pure substances such as benzoic acid can form crystals, leaving impurities of the acid behind in the solution. The recrystallization method works best once the solution is highly soluble in a heated solvent, yet highly insoluble in its cooled form. The compound must be solid at room temperature. Purpose of recrystallization. Recrystallization refers to an impure compound being purified by removing any impure properties within the solution. The purpose of recrystallization for this experiment was to start with an impure form of benzoic acid and go through the process of recrystallization in order to create a more purified form of the benzoic acid. The process involves dissolving about 1 gram of impure benzoic acid in boiling water, with any impurities removed through filtration and absorption. The addition of decolorizing charcoal to the benzoic acid effectively removed any pigment by binding it to the impurities and absorbing them.
On this slide we go into a little bit more detail about the process of recrystallization. In figure 1, the first step is shown, in which impure benzoic acid is measured. This later helps determine its level of purity. In figure 2, we see the boiling of the mixture, which now includes the solute and the solvent. In figure 3, we see the addition of decolorized charcoal to the mixture while it is still at its boiling point. In figure 4, we can see the mixture being poured through a funnel lined with filter paper. This is done in order to catch all that charcoal that has been placed in it beforehand. Figure 5 represents the cooling down process, in which the mixture is put into an ice bath until crystals have formed. Figure 6 shows us the final filtration process our mixture goes through. Now figure 5 and 6 will be discussed in more detail right after this slide. Continuing on, figure 7 shows us the drying of the crystallized solution in an oven set to 80 degrees for around 10 minutes. This is done to make sure all additional moisture has been removed from the crystals. Figures 8 to 9 show the process of transferring the crystals from the watch glass into the capillary tube, and finally figure 10 shows the process in which the melting point is determined.
Crystal extraction. When benzoic acid is taken off the heat source, it begins to crystallize. After the flask has reached to room temperature, it is submerged in an ice bath. Benzoic acid crystals are left behind after the liquid is removed using vacuum filtration.
Filtration is used to separate insoluble particles from the solution, and in this case of the experiment we had benzoic acid crystals, which we used a Hirsch filter, and then we attached that to a vacuum to help pull the solution through. And then the solution went through the Hirsch funnel and we were left with benzoic acid crystals on the top. Determining the melting point is used as just a quick check to see how pure our product is, because our desired product is benzoic acid, and the melting point of benzoic acid is known to be at about 122 degrees. And if our product's melting point is close to that, then we know that it's pure.